Good day, friends. In chemistry class today, we'll be looking at the topic molecule shapes. And what do we mean by that? We are looking at the shapes of molecules. We have some molecules at this level that you are to be able to identify their shapes. And one of them, we'll be looking at water. So let's look at the real molecular shape for water. So I'm going to do this. So we look at this. This is the shape, the real shape of water molecule. And when you talk about water molecule, the main central atom, that is the middle atom, is oxygen. And this is represented by the orange diagram. And then you have the hydrogen, two molecules, which is represented by the white circle. And what is the name of the shape of water? We call it bent in chemistry. At times you might not see it as bent. You might see it as a V shape. And if you look at it, it's like an upside down V. So it's either you call it a V-shaped molecule or you call it a bent shaped molecule. Let's see if the electron geometry, that is the electron shape, is similar. No. So why is this not similar? We are having tetrahedral. Tetrahedral means you are having four particular atoms in general around the central atom. And why is this so? We have hydrogen around this orange atom. And don't forget, I told you, we have what we call lone pairs. And when you say something is a pair, you are talking about two molecules. So 2 plus these 2 hydrogen make 4 around that central atom. And that is why the electron geometry, most of the time, is always different from the molecule geometry. So don't forget, class, the molecule geometry of water is called what? Good, bent shape. While that of the electron geometry for water is called tetrahedral. Very good. Let's look at another molecule. And that, we are looking at carbon 4 oxide. This is carbon 4 oxide. And the central atom in this particular molecule is your carbon. So the carbon is represented with the diagram there, or the white shape. And then your oxygen is represented with the orange shape. And then why do we have double bonds? We call these bonds. So why do we have double bonds connecting this oxygen to the central atom, which is carbon? All because your oxygen needs about 8 electrons to be stable. So these 2 bonds represent 4 good electrons. So in this case, if you look at the shape, which is our business for today, it is straight. And when we say something is straight in terms of shape, we call it what? Good. We call it linear. So this is a linear shape molecule. And if you look at this, the electron geometry is similar. And why is this so? We don't have any lone pairs. As you can see, there are no lone pairs. You can't see any dot above the central atom. That tells you that we only have 2 things around the central atom, and they are arranged in a linear form. And that is why the electron geometry and the molecule geometry are linear in shape. Yes. Another thing I would also like you to know, which you can be asked in any of your exams, the bond angle. And when you talk about the bond angle of a straight line molecule or shape, we usually say is what? 180 degrees. Okay, so the bond angle for water, as you can see, for carbon 4 oxide is 180. And why is it 180? Because the shape is linear. The shape is what? Linear. So when you have a linear shape, you expect the bond angle to be 180 degrees. Let's take one more example. So let's look at another molecule, and that is sulfur 4 oxide. And if you look at sulfur 4 oxide, the bond angle is 119. This is a bit similar to the water molecule. Don't forget, when we were looking at the molecule geometry for water, we said it was bent. Same thing with sulfur 4 oxide. It's also bent, but there is a difference in the electron geometry. The electron geometry for water was tetrahedral, if you remember. Because why? We're having 4 things, including the lone pairs of electrons. But if you look at your sulfur 4 oxide, we only have a lone pair, unlike in water molecule, where we have 2 lone pairs, making it 4. So in this case, we're having a lone pair, we take it as 1. Then we have our sulfur, we have the central sulfur, we have 1 oxygen, the second oxygen, making 3 things around the central atom. Now, because 3 things are arranged around the central atom, we say the electron geometry is called what? Tri. And tri represents 3 in number. So we call this trigonal planar. And when we say something is planar in terms of shape, if you look at the base is not taking any form of a particular shape. So we call it trigonal planar. But the molecule geometry is always called bent. Let me take you to one more example that is a bit similar to this, and that is ammonia. So let's look at ammonia. Ammonia, good. This is ammonia, and the central atom in ammonia is our nitrogen. So it is represented by the blue circle. And then we have our 3 hydrogen attached to ammonia molecule. But ammonia molecule has what we call a lone pair of electrons. And that is what you're seeing here, the dots, the 2 dots. So we have a lone pair trying to compress those other hydrogen in order for the bond angle to be a bit lower. Let's look at the molecule geometry. The molecule geometry for ammonia is trigonal pyramidal. Why do we call it a pyramidal and not a planar? It's because by the time we draw the complete shape of what is below in this, it takes the form of a pyramid. And that is why instead of calling the molecule of ammonia trigonal planar, we rather call it trigonal pyramidal. Now let's look at it. The electron geometry. Why is it tetra? I told you earlier on, yeah? Good. 4. We are having about 4 electrons around this. Don't forget our ammonia is having 3 hydrogen, 3 things. And then we have the lone pair. We take that as 1, making 4 things arranged around the central atom. As you can see, the molecule geometry for ammonia is called trigonal pyramidal, while that of the electron geometry of that same shape is called tetrahedral. Haven't learned about the shapes, the bond angles of molecules? I would like you to take this on your own. So let's look at it. So you are going to take the BF3, boron fluoride, and then you tell me for methane, that is the CH4. So take that, and then in our next class, we'll see you again. Thank you.